Take your stuff with you and check out in the attendance office at the correct time, okay?
Yeah.
All right, here we go. We are still in section 4.1, and I think we're ready for 6C, is that right?
Yeah.
All right, so we have an archery target. Concentric circles, I'm not very good at drawing, but that's what concentric circles mean. It says the circles are 6 inches apart. Okay, so this right here is 6 inches. The inner circle, so this guy right here, has a perimeter, probably ought to call it circumference, of 37.7. Our job is to find the circumference of the pink circle. Perimeter for circle is circumference. Yeah. Yeah, I mean, yes, if you want to call it perimeter, that's fine. But for circles, we normally call it circumference, right? It's the distance around. Now, for the black one here in the middle, we know the distance around is 37.7. Anybody know the formula for circumference? 2 pi r. Who said that? I think you're wonderful. 2 pi r. So if 2 pi r is 37.7, can we find r for this black circle? All right, so r will be, I'll do it on my calculator, 37.7 divided by, now be careful you guys, when you divide by 2 pi, you have to tell the calculator to divide by both. Otherwise, it'll divide by 2 and multiply by pi. So we can put it in parentheses, divided by parentheses 2 pi. We need a calculator every day, guys, so you need to be in the habit of learning a functioning calculator every day. You need to charge it, you can charge it. Ideally, that would be done before class. What did you get for the radius? I got 6. So the radius of the black circle is 6. Everybody with me? Now I need the circumference of the pink circle. Well, what's the radius of the pink circle? 12. So the circumference of the pink circle is going to be 2 pi times 12. Which, I could just say 24 pi, but since the other one was a decimal, I'll figure that out. 24 pi. Did you get 75.4 basically? Is that it, sis? Everybody good? Okay. D, we have a compass. We didn't talk about this, right? I don't think we talked about this before, so I want to make sure everybody's clear on how this, how these things are identified. So here's your compass. Y'all know north, south, east, and west, right? That part you know for sure. Do you know this is called northeast? Okay. Now, so obviously, this is a 90 degree, so that angle is 45 and that angle is 45, because I split it right in half. Well, if I split these 45s, now all these little angles would be 22 and a half. And this one, right here where I'm pointing, this one is labeled north, northeast, And this one is labeled east northeast. Now, I don't want you to memorize that because, oh my gosh, that's too much to memorize. What I want you to do is understand why. This is the northeast line. I subdivided this part of it and this part of it. This part is on the north side of the northeast line, so it's called north-northeast. This one is on the east side. There's east. It's on the east side of the northeast line, so it's called east-northeast. All right? Without looking at your paper, this right here would be northwest. What would this be called? Good. West, northwest. That's exactly right. You've got it. And all of the increments are 22 and a half. Because we took the 90 and split it, and then we took the 45s and split it. So, on the compass, north is 0. South is 180. East is 90. West is 270. That is how angles are labeled in navigation. So anytime a ship is sailing, an airplane's flying, that's what we label it. So now they're saying, what would be the angle measure for northeast? So what would be this angle measure? If that's 0 and that's 90, this one would be 45, easy. How about north-northeast? That one would be 22.5. All right, here comes the tricky one. West-southwest. Here's southwest, right? This is west-southwest. Make sure you got that. So now you need to know this angle right here, all the way around. Always start at north because that's 0. So we're all the way around to here. Any thoughts on what that might be? What? 247.5. Is that, yeah, I think she's right. I think she's right. 247.5. Is that okay with everybody? All right, that was easy enough. All right, now you're going to draw your own. Sketch a diagram. You don't need to do the whole compass. Just sketch the course for 35 degrees. What would 35 degrees look like? Again, don't draw the whole compass. You don't need it. Where's 35 degrees going to be? Up here, right? Would that be 35 degrees? So that's all you have to draw. Where would 128 be? Down here. All you have to do is get it in the right quadrant and label the angle. That's all. Everybody okay with that being down there in quadrant 4? And then 310. 310 is going to go all the way around to here, right? Label that angle 310 degrees. That's all you have to do. Now, F is the same thing, except it's kind of like 2 layers. So here's my compass. Here's my ship, the tourist boat Julia out of Oak Harbor. Okay, so here's Oak Harbor. And he's following a 38-degree course for 2 miles. So 38 degrees would look like this. Would you agree with that? Remember, you always measure from due north. Let's label that 2 because that's 2 miles long. And then he changes course. So here's a new compass. And now he's changing to a 47-degree course. Always measured from due north. So here's where he is after his first leg of his journey. There's my compass. There's a 47-degree course, and that one is 4 miles long. So now he's here. That's it. All you do is draw the course. Got it. Everybody good? All right, next problem. 2 Coast Guard patrol boats. Okay, so we have the picture. Boats is 4230. One of the boats is 5212. And they're both 25 miles from Cape May, so these are both 25. And we want to know how far apart will they be. Would you agree that this is their distance apart? What I need you to understand is this is really all part of a big circle. And so their distance apart, I'll call it X, their distance apart isn't really a straight line. Their distance apart is like an arc. It's part of that circle. So if I could find the blue arc, and I could find the pink arc, would their distance apart just be pink minus blue? Yep. How do I find arc length? Oh gosh, this was yesterday. We talked about this. What? Okay, so arc length is radius times radians. Now, we know that our radius is 25. But we have an issue with the angles because these angles are in degrees. So pi over 180 equals something over 4230. So x equals 4230 pi divided by 180. Remember that from yesterday? So I'm going to go ahead and type that in on my calculator. So do you remember how to put in 4230? So 42 degrees. If you've forgotten, lean over and ask your neighbor. 30 minutes times pi divided by 180. For the blue angle, the 4230 angle, I got 0.742. Somebody else do it and tell me if that's what you got. Okay? Now I'm going to do exactly the same for the pink one, 5212. So pi over 180 equals something over 5212. So we'll figure out that pink angle in radians. Did you get 0.911? Now actually, now that I think about it, if I know that the blue one is 0.742 and the pink one is 0.911, can I find the little one in between? Maybe do that, maybe that'll be easier. So 0.911 minus 0.742, 0.169. Eli, how did you say we find arc length? So I know my radius is 25. I know my angle is 0.169. I'm going to multiply them together. And those ships are 4.225 miles apart. 4.225 miles. Now that was a lot. So let's back up and make sure you kept up with that. The answer to the question is this little arc length right here. We know that arc length is radius times radians, and we know the radius is 25. So we needed the radian measure of this angle. So we found the radian measure of the one angle, 42, the radian measure of the other angle, 52. We subtracted those and got the radian measure of the angle, times it by 25, and got the answer to the question. I got 4.225 miles. All right, for this next one, guys, I am not going to do all of this because it's all the same. So let's pick a car. You want to do the Ford Taurus, the Dodge Charger, or the Mercury Mariner? Ford Taurus, okay. So here we go. Find the speed of the Ford Taurus when the wheels are turning 800 revolutions per minute. Now, I don't want you to be confused. You've got a wheel, and for the Ford Taurus, what's the radius? 13.08. So here's my wheel. I know right now that it is turning at 800 revolutions per 1 minute. That's what I know. I need to ultimately end up knowing miles per hour. That's my goal. How many miles per hour? So somehow I got to get from here to there. Now I want you to look at this wheel for a second and need you to understand that every time that wheel goes around, it covers a circumference of ground. Would you agree with that? So one revolution is the same as one circumference. So what would be the circumference of this wheel? 2 pi r. So 2 pi r would be 26.16 pi inches is one revolution. Would everybody agree with that? Now, from chemistry, I set this up like this purposefully because what do I want to happen to these units? I want them to cancel. So this is true. It could be set up the other way, but upside down. But if I did it upside down, they wouldn't cancel. And I want them to cancel. Now I've got inches per minute. That's what I got. So I need to get to miles. I don't know how to get straight from inches to miles, so I'm gonna have to go to feet first. So I know that 1 foot is 12 inches. Would you agree with that? And then I know that 1 mile is 5,280 feet. Yes, you're supposed to know that. That's just one of those things. So now what have I got? Let's cancel out the units. Where am I now? I'm in miles per minute. So I need one more thing. What is that last thing then? I know that 1 hour is 60 minutes. So the minutes will cancel. And look at the units that are left.
Miles per hour.
Which is exactly what I wanted. So now to get the answer, we're going to multiply everything on the top. And we're going to divide by everything on the bottom. And on the bottom, you're either going to have to put parentheses or you're going to have to divide individually. So divided by 12, divided by 5,280. You need to make sure the calculator is dividing by both of those. So 800 times 26.16 pi times 60 divided by 12 divided by 5,200. How fast is our Ford Taurus moving? 62.26 miles per hour.
How did you know that to use the 26.16 pi?
Okay, the key here is to remember that a revolution is a circumference. So what's the circumference of this wheel?
Oh, 13.8. Oh, so
13.08 is the radius.
Radius.
So 2 of those times pi.
Okay.
Yeah. So this is critical. Okay?
Yeah.
Gotta know that. Any issue with that? Everybody okay? As you set it up, just like you did in chemistry class, as you set it up, be thoughtful and remember that you need the units to cancel. So if you've got inches on the top, you need them on the bottom, and so on. All right, last one. Then we'll go to lunch. Kathy races on a bike with 13-inch radius wheels. So Kathy's bike has wheels that look like this. When she is traveling at a speed of 44 miles per hour, how many revolutions per minute is she making? Would you agree that this is basically the same problem but backwards? So this time, we are starting with 44 miles per 1 hour. That's what we're starting with. And we eventually want to end up with revolutions per minute. So Meg's question hit on the core of the problem. What do I know about revolutions? I got to get revolutions in my problem. What do I know about a revolution? It's 1 circumference. So 1 revolution is 26 pi inches. Would you agree with that? Now, I've got my revolution, it's all good, I gotta worry about the rest of the stuff now. I got hours down here, I need minutes, so 1 hour is 60 minutes. So hours are gone. I've got my revolutions per minute. Oh, I've got miles and inches I have to get rid of. Does everybody see that? Miles and inches don't cross off. So where am I gonna go next? So let's see, I need to cancel my inches. So 12 inches is 1 foot. And 5,280 feet is 1 mile. See, this is just kind of like a puzzle. So the miles are gone, the feet are gone. Do I have it?
Yeah, or do we need to get rid of? Yeah,
I've got revolutions per minute.
we're doing, yeah, we're good.
We're good?
Let's get it.
Is everybody good?
Yep.
Type it in. Here we go. Then we're going to lunch. Type it in, everybody. You too, Peter. Remember, this denominator can be very tricky. You are dividing by all of this. 26, pi, and 60. You're dividing by that whole thing. Whoa. What did you get?
5,600.
I got 568. So check for a 10 somewhere, Braden. I got 568.84 revolutions per minute. If you can't get it, Braden, I'll help you out before you get back. All right, folks? All right. We are back in our seats at 49.
49.
49. In